Hello, everyone. This is going to be section 3.1, class notes exercises. So first, we're going to consider a couple of predicates, and then we're going to see if they're actually true or not. So on the first question, we have the predicate p of x is x squared minus 5x plus 6 equals 0, and the domain is with the real numbers. So we want to know if p of 2 is true. Well, p of 2 is 2 squared minus 5 by 2 plus 6. And this is equals to 4 minus 10 plus 6, which is actually 0. So it is true. So this is true. P of 3. For P of 3, we do the same thing. 3 squared minus 5 times 3 plus 6. But in this case, this is going to be 9 minus 15 plus 6, which is going to be equals to 0 as well. So that also works. Now, P of 0 is 0 squared minus 5 times 0 plus 6. This is actually going to be equal 6, which is different from 0. So it's not going to be true. So the value of 3 of 0 is false. So this will be true, true, and false. Now for question number 2, let's check some other predicates with different domains. So we have that p of x is now x plus 3 equals 7 with domain C. And so if we solve to find the truth set, we will have to solve the equation x plus 3 equals 7, which will give me x equals 4. So the truth set is going to be just 4 for this one. Since this belongs to the integers, then that's fine. Now, x squared equals 16 with domain integers. We do the same thing. X squared equals 16. This is equivalent to x squared minus 16 equals 0, which is x minus 4 times x plus 4 equals 0. And that implies that either x minus 4 is equal 0 or x plus 4 is equal 0. And so that means x equals 4 or x is equals minus 4. So the truth set here is going to be minus 4 to 4. This is the truth set for this predicate. Now, if we have r of x to be the x less than 5, and the domain is the numbers 1, 2, 3, 4, 5, 6, then the truth set for this particular predicate is just going to be 1, 2, 3, and 4. Notice that 5 doesn't work because 5 is not less than 5, so it won't work in this case. So, all right, moving on. Question number 3. Let's write each of this statement in symbolic form using quantifiers. So it says all real numbers are positive or negative or 0. And so we can write this as for all x that belongs to the real numbers, this will be all real numbers, are either positive, negative, or 0. So we can say x is positive or x equals 0 or x is negative. This would be the symbolic way of writing that. B, there exists an integer that is even and prime. So there's a couple ways that you can write this, but since there is no symbolic way to say that something is prime, we can start by saying s is n that belongs to the integers, so that x even n x prime. And this will be a symbolic way of doing that. Now, every student in this class has taken calculus. So we can say for all s that belongs to S, where S is the set of students of this class, and so we can say S has taken calculus. You can, of course, define a predicate P of x as x has taken calculus. And if you do that, then you can just write for all s that belongs to S, then you have P of x. Now, we have some rectangles are squares. And so we can say assist R that belongs to the rectangles so that R belong to S, where R is the set of rectangles and S will be the set of the squares. Maybe this will make more clear that it's a rectangle. Question number 4 is determine whether each statement is true or false. If false, provide a counterexample. For all n that belongs to C, n squared is bigger than 0. Well, this is true. Remember that the integers, they are the positive naturals. And for all naturals, the number squared is going to be bigger than 0. Bigger or equal, particular 0 is also 0 squared is bigger or equal than 0. So this is true. For all x that belongs to the real numbers, x squared is bigger than 0. Well, this is false, of course, because this is saying for all real numbers. And you can actually take x equals 0, and 0 squared, which is 0, is not going to be bigger than 0. It's the same, it's equal. But this is just saying that this is strictly bigger. Now, C says for all n in the integers, n squared is bigger than n. And this is true. This is true at least for the integers, because for the integers, we have that integers are bigger than 1, right? So we can start by n is bigger than 1. So n squared will be bigger than n. So that'll be for the positives. And if you say that n is equal 0, that also will work. N squared will be 0 as well. And if n is less than 1 or negative, then you're going to have that multiplying by n. So if I multiply by n this inequality, because n is negative, is going to flip the inequality of order, and I'm going to get n squared bigger than n. Remember, if n is negative, when you multiply an inequality, it flips the inequality. So notice that for all these cases, it holds true. Now, number 5, determine which each statement is true or false. If true, provide an example that demonstrate that. Is this an x such that x squared is minus 1? And this is false, because there is no number such that in a square is going to produce a negative number. That never will happen. Is this an n that belongs to the integers, so that 2n plus 1 is equals 8? This is also going to be false, because in particular there's not going to be an integer. If you solve for this, you solve here, 2n is equals 7, and n is equals 7 over 2, and that does not belong to the integers. This is a real number such that x squared minus 2x plus 1 is equals 0, and this is true. So this is false, and this is true. And the reason why this is true, you can plug x equals 1, and you will notice that 1 squared minus 2 plus 1 is equals 0. Okay? Now, question number 6. Consider the predicate P of x is absolute value of x is less or equal than 3 with domain C. Let's find the truth set of this. So now, the fact that x is less or equal than 3 can be seen as x is between minus 3 and 3. But because this is domain of the integers, this means this is minus 3, minus 2, minus 1, 0, 1, 2, and 3. This is specifically this truth set. Now, is for all x that belongs to C, P of x true or false? This says for all x that belongs to C. Obviously, this is going to be false, because not all integers have absolute value less than 3. Is only we're taking like minus 4. And if you do minus 4, absolute value of minus 4 is 4, which is actually bigger than 3. Is this an x that belongs to C such that P of x true or false? And so, yeah, there are going to be integers with absolute value less than 3. But there's going to be others like minus 4 where that's going to be false. So x equals 0 makes it true. X equals 4 make it false. So that depends of the value that you're taking. Okay, we'll continue this on video number 2.